In this video, I want to show you how to do F equals ma, or Newton's second law problems with multiple objects. And so you have multiple objects, but you also, more importantly, have multiple tensions. And these are two different tensions. So I hope you can see that, and I'll explain why. So there are now actually three different tensions. One of them you know. So what this one asks is find every unknown tension. Now let's go back to our method. uh, I say NFAT. I don't find the normal because there is no friction. However, I could see an NFAT. I can't find my tensions until I know about my acceleration. And that's easy to do because we have this front tension, and this front tension, I can use F equals ma to find the acceleration because I know F and I know m. So this force does what? Always ask yourself that question. This force accelerates all three bodies. This force accelerates these. I could just consider this as one 10-kilogram mass, couldn't I? And that's what we're actually going to do. So we'll do F because we want to find acceleration. I'm going to do sum of the forces equal ma. Let's just look at this 210 Newton force and always ask ourselves, what is it accelerating? Well, it's accelerating three bodies whose mass is 10 kilograms. And what would the acceleration be? 21 meters per second squared. And that's simple. Now, why did I get that? Because now I could find the tension T1 and T2. I want you to recognize that all three bodies will have the same acceleration, 21 meters per second squared. So now I'm going to get T1 and T2, I'm going to do F equals ma two more times. Now, I want you to recognize that this is 210, but these two forces are going to be less. Why? Because the 210 Newton force accelerates three bodies. The T2, what does it accelerate? It only accelerates two bodies. And T1, what does it accelerate? One body. So 210 accelerates 10 kilograms, 532. T2 accelerates 5 kilograms. T1 only accelerates 2 kilograms. So now that we have the acceleration, let's get T. I always like to go at the end. I always like to do easy first. Sum of the forces. Now we're going to isolate this and get tunnel vision, which is totally okay. Sum of the forces in the x direction equal ma. What's the only force? There's a positive force of T1 equals m2. Now I'm going to make all these two significant digits. Remember, all my handouts make them at anything given, make it at least two significant digits. So the acceleration of this body is 21 meters per second squared because all the bodies will have an acceleration of 21 meters per second squared. So T1 equals 42 newtons. Okay, now let's clean this up a little bit. And we have to get T2. Now T2 will have a greater tension because T2 is accelerating these two bodies. And so I'm going to get, now what I'm going to do is, isn't it true, and remember it's frictionless, isn't it true that the sum of the forces in the x direction equal ma, and that I'm allowed to say I don't have 3 kilograms and 2 kilograms, I have one box that's 5.0 kilograms, and it has only one force on it because there's no friction. T2 going to the right, going to the positive direction. So that's 5.0 times 21 meters per second squared. So that would be equals ma. Let's take a look. And that would be T2 equals 105 newtons. Okay. So that's how you do it. When you have multiple bodies in your system, you have to isolate each part. To get T1, I have to recognize that it only accelerates the 2 kilogram mass. To get T2, I recognize that it only accelerates 3 plus 2, a 5 kilogram mass.